Hey everyone, welcome back to my channel. Last time we explored how the one-time pad is the only perfectly secure cipher out there. Now we're going to build it ourselves with some Python coding. And without further ado, let's get into it. Now let's do a quick recap. The one-time pad uses a random key which has the same length as your message. So if the message is 16 bits, the random key is going to be 16 bits. This is an example. We will combine these two using the XOR operation. So the same bits, so 0 XOR 0 gives 0, 1 XOR 1 gives 0. So when the bits are the same, we receive 0, and when the bits are different, we receive 1. So what we will do, what our Python program will do, is it will encrypt our message, which is going to be hello, with a key, and you will get the encrypted message or the binary ciphertext, which is going to be something random, and we will decrypt it, the ciphertext, with the same key, and boom, you will get back hello. And what's the catch here? That we will use the key only once per message. Let's get into coding. First, we need Pygame for the visual part and some async IO stuff to run it in a browser with PyODide. Now I will set up the whole thing and then I will explain it to you guys. So this is the setup. We initialize Pygame here, we set up the screen, and when I run it you guys will understand what this setup is or how it looks like, and these are the colors for the setup. Uh, but before we go ahead, I would like to remind you that you will need to install Pygame if you haven't already by opening the terminal. So going here, opening a terminal, and then going pip install Pygame. I have already done this, so I don't need to do it, but if you guys haven't, then please go ahead and install Pygame locally. And now let's get into it by writing the first function, which is going to convert a text to binary. So this function is going to turn our message into binary. It grabs each character from the text. It grabs each character's ASCII value and it formats it as an 8-bit, and then we finally return it. And it's the same deal for turning binary back to text. So let's start writing the function. And this is the function. We go through 8 bits at a time, or 1 byte. We take those 8 bits, we convert them from binary to a number. Then the number that we got, we convert that number into a character, and finally we assign that character to the text variable. And lastly, we just return the text. Now we're gonna go into the heart of the one-time pad. We're gonna start with the encryption function. It will take a plain text and key. It will convert them to binary and XOR them bit by bit. If the key is shorter, we will pad it with zeros, but keep in mind that this is not ideal, but it works for our demo. So let's get into it. So this is the encrypt function. We have the plain text binary where we call the function up here that we created, text to binary, to convert a text to binary. We call that to convert the plain text, and then we also call it to convert the key to binary. Then we do the checking when, as I mentioned, if the size of the key is less than the messages, then we just pad it with 0. But keep in mind it's not ideal. And then we finally create this ciphertext binary, and then we return it. Now I will do the OTP decryption, which is sort of similar. And this is the decryption function. We grab the binary version of our key, and then we check if the binary, so our key, is less than the ciphertext. Then we pad it with zeros. Then we retrieve the binary version of our plaintext, and finally we call the binary to text function with our binary plaintext in order to receive the plaintext. Now I will set up the game and we will then run to see what the result is. And this is the game setup. This will be our plaintext, this will be the key, and the ciphertext is going to be whatever our encryption function returns, and the decrypted text is going to be what our decrypt function returns. Now I will do the last thing, which is the main loop, and we can finally see how our program works and what it looks like. And here is the main function. Now, as I showed you before, I have hard-coded the hello as the plaintext and the key as something random. We would want it to be random. Now let's run the code and see what is the result. Okay, so as you can see on this window that was displayed, we have the plaintext, which is hello, the key, which is random, and the ciphertext is here in green. So it's just a random combination of bits between the key and the plaintext. And as you can see, we have 5 letters here and 5 letters here, which indicates that they are the same length. Uh, and also, as you can see here, the decrypt is also hello. So this indicates that our decryption function works. If you guys want to make it cooler, we could add user input for the message and key using Pygame's text input. I'll show you the idea. Imagine typing your own secret message. For now, this demo keeps it simple, but I might add that in a follow-up video. What do you think? Do you want to see that? Before I wrap things up, here's a quick tip. In real life, the key must be random, as long as the message and shared securely. For this demo, I used a short key for simplicity, but don't do that outside the control test. The one-time rule is what makes this cipher unbreakable. That's it for today's code. We have built a working one-time pad in Python with Pygame. Play around with the code, tweak the message or key, and see what happens. If you like this, smash the like button, subscribe, and drop your thoughts in the comments. Until next time, have a good one.